All right, welcome back, Environmental Science. So today we're just going to pick up some of this rivers and stream stuff we've been talking about. Hopefully you got the chance to see my other video I posted for you in the Google Classroom. It's just some small little information things that we would talk about in class, just kind of jam-packed into a fun adventure. So hopefully you enjoy it. But I'm going to talk about some of the lecture notes here today. So you can review these and kind of get an idea of what we would be talking about for our stream team project if we were in class. So rivers and streams, humans interact with the environment. Our objectives are to discover where rivers and streams begin, determine human impacts on rivers and streams as well. And again, we've talked about rivers and streams and how vital they are to us because a lot of these rivers and streams lead into our water supply, which is our drinking water. So we do want to be concerned about what is being dumped into our drinking water, just like in the case of Flint, Michigan. So water location. Most people agree that water is important, but did you know most of the water in the world is in the oceans, bays, estuaries, and salt marshes? You're like, well, duh. Yeah, like 2/3 of the planet or more is actually covered in water. The landmass that we live on is actually the minority compared to the large majority of water on Earth. Okay? However, only about 3% of Earth's water is actually fresh water, which means only 3% of the entire world's population of water is actually drinkable for us. And only 1% of all that fresh water is surface water. Okay, so we're dwindling down pretty quickly. So as you can see from the pie chart, all the blue is the oceans and bays. Here you have the polar ice caps and glaciers, which make up that little piece there. You got the aquifers, which make up that little white sliver there, and then you actually have surface water there. So we're talking about a pretty small amount for water that we actually use on a day-to-day basis. So yeah, lots of water out there that we need, but yet a lot of it is undrinkable. So ice caps and aquifers. Most of the world's fresh water that is non-salty is frozen in the ice caps and glaciers or lies underground in aquifers. So even then, most of that surface water is a very, very, very small amount. All right, so when we talk about the glaciers and the ice caps, I mean, you look at this thing could be 12 feet tall, and that's just solid ice all the way back. You got snow up there too, and of course you got Bear Grylls. Eats lots of vitamin C to keep the glaciers or glaciers away. Yeah, so a little Bear Grylls fun for you there. But yeah, so ice caps and aquifers. As you look here, you can see increasing groundwater stress. So these are the areas that is groundwater that has been stressed somewhere in the world. Blue's looking like okay, it's not too bad. I mean, it's got a little bit of stress. Red is really bad. So as you look at places like India, even down here and towards the desert region here of North America, you've got some places stressed. You've also got some yellow or moderate regions, especially right here in the Midwest. You're like, what the heck is that? I didn't realize we had some aquifers down there or ice caps. Well, we don't have ice caps in the Midwest, but we do have an aquifer called the Olagala Aquifer. It's a massive aquifer that spans all the way from the Dakotas all the way down to Texas. And a lot of farmers in Kansas and Nebraska pump this water out of the ground to irrigate their crops. And if you've ever traveled through Kansas and Nebraska, you'll notice they have these big long irrigation systems on wheels that go around and around and around, and that's to water their crops. That's a big impact on their crops because it produces lots and lots of yield for them because they don't get as much rainfall out there as compared to Missouri or Illinois. So big difference in crop production. So if they didn't have this, it could be a big economic impact down the road. Problem is they are taking more water out than water is being put back in, which means it's quite possible they could actually dry up this aquifer and then we're really in trouble for the future. So we have to be wise and conserve the water that we do have in these areas. All right. Native or negative human impacts. People are using and abusing the water at an even faster rate. So, what I mean by this, as you look at these photos here, in some third world countries and stuff, they have garbage just spewed out into their bays and oceans and stuff like that. Even in well developed countries like Rio here, where the 2016 Olympics were, um, the Games Committee said, yeah, we would like to have it here. This is a great place. And then many athletes started looking at this area and they realized that this was like almost, they were going to swim in this bay for some of the events. It's like swimming through raw sewage. I mean, I don't know if I'm a highly paid athlete, I don't think I want to swim through that. So they got really upset about this, and the games committee said, you got to clean this up or you're going to be in some big trouble. So they actually did. They would clean up their beaches and all this stuff. So it can be done. The question is, will we do it? As we look out there in the Pacific too, we have the large Pacific garbage patch, which is accumulating massive amounts of garbage. And it's a lot of times like plastics, plastic bags. It could be beach balls. It could be lawn chairs. You name it. Everything's out there. And it's not just in the Pacific. There's multiple places out there on Earth where all this garbage is accumulating. So we're having problems picking up after ourselves. All right. As you look here too, sometimes we have the oil spills, and as we're deep sea drilling for oil to help for that gasoline price, sometimes we have those problems like Deepwater Horizon, which the oil starts to come out of the ground because of an accident and starts polluting the oceans. So we have to burn stuff, and that causes problems. We release chemicals to take care of the oil, and that causes problems. So we're just having this downward spiral effect of contaminating the water as humans, even though we don't live in it, which is crazy. So surface water, the water collects on the surface of the ground. It is easy to access by humans, animals, and plants. It is easily polluted by human activities. And you're thinking, well, I don't pollute the water. I don't go out there and dump stuff. That's true, you don't. But you may drive a vehicle, and your vehicle may, lose some oil, antifreeze, brake fluid on the road, and then it rains and it goes into the ditch. And when it goes in the ditch, it goes into a stream, and that bam is in our drinking water. Yeah. So indirectly, we're not necessarily trying to do that, but we can have some problems doing that. All right. So there's been cases of they're finding high amounts of caffeine in fish. Like what? Why caffeine in fish? A lot of the soda drinks or coffee that we drink and stuff like that, we dump out on the ground, and that goes into the streams and rivers, and that gets eventually into a bigger body of water, which the fish would then swim in and uptake. So yeah, we're getting some wild and crazy things happening in our environment. So it's easily polluted, even by a simple, mistake. It molds and shapes the earth through erosion and deposition. It flows in predictable patterns as streams and rivers. Which direction does water actually flow? Now, I want you to think about this. Look at a map and think about all the rivers that you see out there and streams. Which direction do they flow? Is it north? Is it south? East? West? I bet you've narrowed in on two of them, haven't you? Well, you're wrong already. Rivers and streams flow in any direction that they want. It's all because of gravity. They flow to the point of least resistance or downhill, essentially. So, as you can see in the picture over here, if there was rain or snow up here, the water just go down the hill. That's what it do. Go to the lowest point possible. So yes, and then there's my Star Wars meme. So enjoy that. Let the water flow through you. Yes, yes. The start of every great journey. Most streams begin in the mountains or highlands. Even the mighty Missouri or Mississippi River, they begin somewhere, usually in mountains. The Missouri River, particularly, begins in Montana. Yeah, you didn't probably know that, but it begins as a small little stream like this. The ice melts, it starts going down a mountain, and eventually gets bigger and bigger and bigger as more water from different locations accumulate and build and make that stream much larger into a river as we get here to Missouri and down as you go all the way down to Louisiana. So we're talking massive amounts of water coming from several different locations. So they collect the runoff from rainwater in mountains. So snow melt in the spring, mountain springs, water seeping out of or between rocks. That's just water sometimes just accumulated from snow. But yeah, so you could actually jump the mighty Missouri or Mississippi River at its origin point, of course. There's probably no way you could do it here locally, so good times. So high altitude streams. High in the mountains, streams are very narrow and flow swiftly, so very quickly, probably because it's steep. Okay, erosion rates are very high. The rushing water moves stones and soil. Why? Because again, the incline in which the water is running at, it can build up a lot of speed and velocity, which can start to move objects like rocks, big boulders, and stuff like that, and create waterfalls too. Natural erosion, streams wear down rocks and form rapids and waterfalls, as you can see in the photo here, like say in Colorado. If you've never went whitewater rafting in Colorado, it's very beautiful. It's a great time. The water is very cold because it's coming off the mountains, but they have a lot of big rocks. Some are sharp, but you can see some of them are kind of rounded though too. And as such, that's because of the water, the tumbling of the rocks down the stream, and whatnot. So whitewater rafting is fun, but very dangerous too, as you can see here. People do die each year from whitewater rafting. So if you go, be very careful. And this little photo here, I found this one and I couldn't stop laughing for about 20 minutes, so I thought I had to put it on there. I mean, this is pure and innocent fear in this dog's eyes. The dog's like, I don't like you anymore. I want to go home. It's just too good. Just too good. So, which way does the water flow during in the diagram? Again, if these were mountains, it's just going to flow downstream from each direction. So this one's going, and this was south. This one's going to have to go east first. Some of these are going to have to go west or south, and eventually they'll wind up here to the bay or the Gulf. That's what happens with the Missouri and the Mississippi River. Okay, lowland water. When the stream descends to flatter land, it becomes wider, slower, and muddier. Why? Because there's less incline. Less incline means less velocity. So it doesn't have, it's basically settling out. It doesn't have a big hill to run down. So all that water starts to accumulate and pool up, and the streams become much, much wider. So as you can see in this photo here, all this water is rapidly rushing off the mountains, and then it gets to the bottom, the valleys, and just nothing much to it. So velocity, again, the steepness of the gradient. Human development along water. Tributaries are smaller, but rivers that join the mainstream, many cities are built along these. So again, St. Louis, you've got different locations. You got Kansas City. All these areas are being built along rivers. It was a great form of transportation. It was much easier than going up and down hills, navigating through trees and brush and stuff like that. They could take boats and barges, and they still use the Mississippi River for barges as well. As you go down there towards St. Louis, you'll see a lot of barges on the river, which is kind of cool. And that transports grain, fuel, all sorts of things that makes commodities easier to trade. So yes, um, rivers were a great transportation system and always have been. That's why many cities that are in North America, inland, are built up around rivers and streams. You don't believe me? Take a look at a map. You'll see that major cities are all near some type of body of water because we need it. Okay. So again, I would in class to have you find some cities on the U.S. map and see where they're built. Okay. So where are the tributaries in this diagram? So this is the main river right here. The tributaries are the secondary pieces right here and here and here. Okay. So they're all leading into one main stream. So technically, the Missouri River is kind of a tributary to the Mississippi River. Yeah, it was kind of weird. Missouri River is like the second longest river or something like that in the world. The Mississippi, I believe, is the longest. Um, but if you recalculate the Missouri from its origin point in Montana to, say, Louisiana, it would far exceed the Mississippi River in length at that point. So, pretty crazy. So people build things to try to control the use of rivers. What is the purpose of each project? Again, as you look at the bridge here, it's just to get across the water, and there's lots of cool bridges being built. There's dams to hold back water for hydroelectric energy, as you can see, like here in Chicago. So just sometimes ferrying people, transportation, things like that. Or you have levees to hold back water, like in Florida. There's Everglades and stuff like that that are basically straight up water and crocodile or alligators and stuff. And you have these luxurious $1 million homes over here that's waiting to be swept away by some type of hurricane. But yeah, so levees, canals, bridges, and hydroelectric dams. When the river meets the sea, you have salt water and you have fresh water. These unique areas do happen, and they are very, very diverse because you have some saltwater organisms and freshwater organisms intermixing. So very, very diverse, almost like a rainforest down here with all the different types of species. Carries its added to the saltwater of the ocean, and that's what we do. Just slowly flows into the ocean. Silt and sediments are carried into the water and deposited, forming a delta. So a delta is basically a lot of buildup of sand and silt. It's kind of mushy and stuff like that. It creates these little pockets. But yes, Louisiana is actually a growing state. Not necessarily for population always, but for the landmass, it's actually getting a little bit larger each year because all the sediments and erosion from all the states, Iowa, Montana, Illinois, Dakota, it's all flowing down towards Louisiana, and as such building up this delta. Middle ground, estuaries or tidal streams with brackish water may be formed near the mouth of a river. So if you ever watched Duck Dynasty, that show back in the day, I'm not sure it's still on anymore, but they were always out there walking around down there in this brackish water. It's got a lot of this, Spanish moss, and the trees are hanging out in the waters. It's a pretty cool area, very diverse, but that's what we're talking about, that middle ground of that fresh water flowing down towards the ocean. So, if you travel from the source of a river to its mouth, what kinds of human activities would you see along the way? Probably a lot of bridges. You might find a few hydro dams. You might find a few dams in general, um, like for holding back city reservoirs and stuff like that. So water supplies. How do the activities upstream affect the people living downstream? Again, um, if you create dams or levees, that water can move faster, and if they don't have the dams or levees, it can cause massive flooding downstream, which can be bad. So yeah, different things. So there's some activities if you want to do them, you don't have to. But it says look up a river, up the Missouri River. Where is its source? We talked about that. What tributaries can you find? There are a number of tributaries that flow into the Missouri River. And where is the mouth of this river? Okay. Well, hopefully you enjoyed this little lecture on rivers and streams. Is just to talk a little bit about human impacts and how it's all connected. So if you guys have any questions, you can always email me. But these videos are just for you to enjoy and partake in. Okay, I'll have some more information later on about the stream team stuff that we won't unfortunately get to do, but I'll try to post a video of what we would have done. All right, so hope you're all staying safe. Take care, guys. Thanks for tuning in.